We are now on our second subtopic, and this time we're going to talk about sampling, compression, and codecs. Okay, so in this part, we'll try to understand more how formats matter. Okay, so okay, before that, let's talk about digitization, or basically the process of converting analog signals into digital signals. So plus, it also concerns with how we are um, presenting our signals or representing our signals when we process them, when we store them, or when we transmit them. Okay, so conversion plus data representation. So that's digitization. And on the conversion part, analog to digital conversion, so just like what you see here, um, okay, so okay, when we digitize, our signals undergo three basic processes: sampling, quantizing, and encoding. So analog signals. We sample, we are actually measuring our signal at fixed intervals. Okay, so kumbaga, it's like taking a picture every second. So one picture every second, or on the microphone after each second. So on, off, on, off, on, off, on, off. So something like that. So that's sampling. Okay. And then since our signals can have different levels, different amplitudes, so we have to limit them because not everything can be accommodated by our computers or by our digital systems. So we have to quantize them. We have to round them off. We have to assign finite levels only. So we have to map them which level each amplitude belongs. Okay, so we have to that's quantizing, and once we have quantized them, we only have limited samples of signals, and we have limited levels. Then since they are already limited in both in terms of time and amplitude, we can now assign a binary equivalent to them. So we can convert them into binary format. Okay, so it's something like this, right? So for example, if we sample our signal, this is if this is our analog signal, or like our voice, for example, then our sampling, it will be something like this. So the red dots, so that will be everything between the red dots will be disregarded. Okay? So we only consider the samples. Like remember in statistics, population sample. So it's similar to this. So instead of taking the entire signal, we only take samples at fixed intervals. And then we quantize them. So their levels assigned to specific quantized levels only. Okay, so uh, most likely there's a rounding off involved here. Okay, and then what's next? We have encoding. So I already mentioned once they are quantized, we have discrete time and discrete amplitude. Or once our signal has discrete time and discrete amplitude, we can now assign the binary equivalent to each one. And I'll show a better picture in the next slide. But in the meantime, take note of our terms, data representation. Basically, once we have digitized the signal, or once we have converted it into its digital form, next is to um, decide on how do we store them and code them in a digital format that would be suitable for processing, storage, and transformation. Okay. And by the way, the sampling, quantizing, encoding that we have discussed is actually the default um, analog to digital conversion technique called So we have additional here or okay. We're talking about a digitation only, analog to digital conversion. And once na process na siya, once it is our digital signal processing or our phones DSP or our laptops or our TVs, smart TVs DSP, then it will be converted in back to analog using the digital analog converter. Okay, so that it can be understood by our analog devices like our speakers. Okay, so now let's try to understand more sampling quantizing and encoding. So for example, we have this signal. I'll try to zoom it in. Okay, so this is our analog signal red one. And when we say sampling, we are considering only finite points in time. So like this. So meaning the in between points are these values are disregarded. Same thing here and here. So the points we only encode these points. So depending on which level they are closer. So for example, this one can be close to 7, I guess. So that's why when we encode that, it has 0111. So point our encoding is 0111, and then here it's 01000, and same thing here. It's closer to here to this level. That's why the encoding is 0011 and so on. Okay, so that's basically how ADC works. And so what's the deal? In our case, take note that um, when we are sampling, we have what we call sample rate. So the higher the sample rate, the better in terms of quality. However, if our sample rate, when we say sample rate, how many samples, how many points in time you get a signal, a portion of the signal in 1 second. So in 1 second, how many times do you represent the signal? Okay? How many times you take a sample? So that's sampling rate. And in terms of quality, the higher, the better. So just like this one, it has more samples compared to the other two. This one has the least one. Okay, so for example, if our analog signal is this one, the blue curve, if we sample it, if we digitize it, it will be like pink one. But at least if we connect the dots, it will be somewhat um, similar to the original. Unlike this one can be tolerated. Medyo nagagaya pa naman. While this one, if we connect the dots, they are far off. If you connect the corners of pink lines, so it's far off already. And that's what we don't want. That's called aliasing actually. And we don't want that. We have to um, we have to make sure that we meet what we call the Nyquist sampling theorem, which says it should be the sample rate should be at least twice of our highest frequency component. So for example, if our voice has up to 4,000 hertz, actually it's around 3,400 hertz only. Ang human voice can produce up to 3,400 maximum frequency component only. Then um, we have to make sure that the sample rate is at least twice of that. So technically, what's happening is we consider 4,000 hertz as the maximum frequency component, and we double it, so 8,000. That's why the standard for telephony for our phones, voice communications is 8,000 sampling. So 8,000 like this. So you'll see in 1 second 8,000 points, 8,000 sample points. So can you imagine? Okay, that's the minimum by the way. And I said in terms of quality, the higher the better. But problem is if you have too much sampling rate, it is too far from the minimum, then you're going to have a problem with the bandwidth naman. So your bandwidth will be compromised. You'll have too high bandwidth because the bandwidth is basically half of your sampling rate. Okay, so if you have a sampling rate of 8,000, you need a bandwidth of at least 4,000 hertz to accommodate that signal. Okay, now in terms of quantization, we have the quantized levels. So the higher the bit depth or the how many bits you assign your quantization process, the more levels you have. So for example, this is a 4-bit quantization. So we can choose from a total of 16 possible values. 2 raised to 4, that's 16. So 16, our values are 0 to 15. So that's a total of 16 values. Okay. While if we do 3-bit quantization, we have a total of 8 possible values. 2 raised to 3, that's 8. So we can only choose among these 8 values from 0 to 7. So the rounding off will be quite inaccurate already at this point. Okay, so there will be a slight variation. Medyo hindi na po, medyo madidistort po yung ano natin, yung signal natin. How much more in this one? So 2 raised to 2, we only have 4 possible levels to choose from for each of our samples. So for example, this one will be considered 0. This one is considered 1. This one is still considered 1. This one considered as 1. Okay. This point is considered 2. This point is also 2, 2. This point also considered as 2. Point considered as 2. And here considered as 3. And so on. So that's quantization. That's the two things that we have to specify when we digitize our signal. We have the sample rate and the bit depth. So in uh, these these two constitute the quality of our signal. So the higher the better, but of course you have to watch out for the bandwidth. Okay? So just like this one, the higher the better. In the case of videos, you a better picture if you have higher quantization. Okay. By the way, in the case of videos, they don't have sample rate, or if sample rate, they have the frame rate. What we mentioned a while ago, the frames per second. Okay. So the more frames per second, the better. The finer the movement. Okay, so here as you can see, if we only have a few colors, then in this case, I think 4 shades of gray only, not 50. While this one, we have a total of 16 shades of gray, still not 50. But that's fine already. Okay, so that's for the second part. Oh, let's try to go farther. Okay, we have to limit our time. So now that we have digitized them, the next problem is compression. So how we represent our data basically depends on how we compress them. So we remember, if we by default our audio and video files are too large, so we have to find a way to compress them, and we have to compress them in a way that they are applicable to our intended purpose. So for example, if if you are very particular with the quality, or in terms of fidelity or the faithfulness of our signal, of our system, then you have to opt for lossless compression. Meaning, this is the type of compression that does not alter much of your data. Okay, so it reduces redundancy using information. So for audio, common format is the FLAC, and for images, common one is the PNG. That's why if you have transparent portions in our image, they are retained if we do lossless compression, especially using the PNG format. Now, if we are more concerned on the file size so that they can be transmitted easy, or they occupy less space in our storage, then we can opt for lossy compression. So it removes perceptually less important information. So there's a filtering out. There's a filtering part in this process. Uh, Whatever is conceived as less or perceived as less important information or something considered negligible, they are being removed or filtered out. So common examples for audio are MP3 and AAC, while for image and video we have JPEG and H.264 for video. Okay, and perceptual coding. This is a special type of compression. It exploits human limitation. For example, if we don't want to hear very high frequency or we don't notice small changes in color, then we can modify our compression technique. Okay. There's also such thing as uncompressed or signals that are files that are no longer compressed. They have no compression technique at all. Okay. So in summary, no, um, of course we cannot everything so technologies that we have that involves audio and video, but here's a summary, a quick summary for comparison purposes also. Now for as you can see, the higher the sampling rate, the higher the bandwidth requirement. Okay, so that's one thing that we have to understand. Also, the higher the bit depth, the higher the bit rate. So bit rate concerns the bandwidth, both the bandwidth and the storage. So higher bit depth or color depth, higher bit rate, which corresponds to higher bandwidth and um, higher storage requirements. So okay, so you can take a screenshot of this. Okay, and lastly, here's another summary. When it comes to codec, by the way, take note that a codec is basically a combination of coder and decoder. So coding in the input side, just like this, once we have our original footage or original sound, they undergo the code. So the codec actually performs the compression part, okay, or encoding and compression. So so that the output will become the file. So that file can be transmitted, emailed, sent to chats, or shown, broadcasted um, over or stored in our database or in our device. Okay, so to access this file, we need a codec. Okay, for the also for decoding or for decompressing our signal. Okay, I think my video froze. Okay, it's okay now. Okay, so that once they are decoded, they can now be accessed. We can now stream them. We can now play them with our multimedia player. Okay, so basically coding everything are types, just not just audio and video. All other computer files that we have under coding, certain type of coding, and so that they can be stored, they can be transmitted, they can be processed, and later on they can be decoded. Okay, so a few standards to take note of. You can take a screenshot of them. Okay, so um, hmm, mhm. I just take note of the uh, a few informations. We're running out of time. Okay, so okay, take a screenshot and now Okay, so that ends our second part. So if you need some more clarification, you have something in mind you want to talk about, you can comment them in our comment section, and you can also write them in our evaluation form. There's a portion where we ask for your thoughts, so you can ask your questions there. And just scan the QR code. And while you are doing so, by the way, there's a quiz also, just like in the previous one. So while you are doing the form, you can watch these videos.